Well, you guys, I'm just going to do a quick limits review for you. So, if this is going to be on the AP exam, I think that there might be one question on there with regard to limits. I'm not sure how it'll be tested. Um, if it is tested at all, there may be a question on limits in the context of L'Hopital's rule. Which I'll do in a separate video and give you a chance to work on that in a separate time. Um, but you should go back and look at L'Hopital's rule also just to refresh your memory with it. But if it is on the test, it'll probably be relatively. I guess I really don't know what it's going to look like, to be honest with you, because we're all in a new world here with this. But anyway, let me jump right into it. So if you remember, when you're looking at the notation for a limit, it is going to look something like this, where when you think about the limit notation, this part, the LIM stands for limit. This part right here is as the x value goes to c, and this is whatever the function is. I would guess for the purposes of this exam, because it's a calculator active, but it won't be a calculator enhanced problem. I would guess that that's probably going to come from some kind of a generic problem, maybe from a table, maybe even from a graph. So, but you'll get practice on that in the delta math thing. Remembering that there is another type of limit notation that we looked at, which was when it was written like something like the following, where there was a plus there after the c, or if you had the limit notation as x goes towards c and there's a minus there, remembering what that referenced is this plus referenced 2c from the right side, and this minus is 2c from the left side. So that's what that, either coming from the numbers that are bigger than c or coming from numbers that are smaller than c. That's the notation. So you might need to look at that. Now, there are three stipulations in order for a limit to exist. Okay? In order for a limit to exist, the limit as x goes towards c from the left side has to be equal to the limit as x goes towards c from the right side. And if those two things are true, and they are actually a finite value, so when you think about what this is just a number. So if it approaches infinity or negative infinity, you can write does not exist. But if those things are true, then the limit as x goes towards c of f of x equals L. But remember, we talked about it being the left side has to equal the right side. And remember, it's as you're approaching it. So when you think about, like, I'm just going to draw a quick graph and and do my best to make an example up. But if I make an example, draw this graph here quick. This may be an easy example, but you'll get the idea behind it. If we label these as 1, 2, 3, 4, 5, 6, 7, 8, we'll just go out to 8. And I won't even label the y-axis, but if we, at least I won't write originally. So let's say I just draw a graph, and let's say I draw a graph that kind of comes into here, and there's an open circle there, and then it goes out, and then maybe it goes to here, and there's a dot there, but then we jump up to here, and we have something like this. And let's say I have a graph. Let's say I give you this graph. Okay, so got a lot of things going on in that graph. And I can even maybe redefine this. Let's just put a dot up there. So I have this graph, and we will label these sides. We'll label this 1, so this is 2, 3, 4, and this is 5, and so on. So if I'm going to go through and do this problem, what I'm going to do it if I look at, let me ask a bunch of different questions. Okay, so let me ask the question, what's the limit as x goes towards 1 from the left side, and we'll just call it f of x. We'll just say that that's function f of x. We'll look at what's the limit as x goes towards 1 from the right side. Let me write a couple more down here. I'm going to scroll back and forth just so you know. What if I ask, what's the limit as x goes towards 1? And then let me do another grouping. Let's do the same thing for 5 and 8. So let's look at those 3 things for 5 and 8. So let's look at the limit as x goes towards 5 from the right side, from the left side. The limit as x goes towards 5 from the right side, and finally the limit as x goes towards 5. And then let's just ask, let me just ask in part G, what's the limit as x goes towards 8? Okay, so we're going to ask these 3 things, these questions based on those 3 points. So here's the picture again. I know that's pretty small. I'll blow it up in a second, but let's just look at the first one. So let's just talk about what's happening at 1. So we kind of can ignore a lot of the graph except for what's happening at 1, right? And if we look at what's happening at 1, the limit as x goes towards 1 from the left side would be approaching this way. And it looks like that's getting closer and closer to 2. So I would say that that's 2. Now what happens as x goes towards 1 from the right side? And it gets closer and closer, and I would say that's approaching 2 as well. So since the left side and the right side are equal, our overall limit is 2. Let's look at what's happening at 5. So now we're going to kind of zero in on what's happening at 5. So, oops. So let me take a look at 5, and if we're looking at it as x approaches 5 from the right side, from the left side, looks like it's going towards 3. Let's say, yeah, from the left side, it's approaching 3. What's happening from the right side? From the right side, we're approaching a value of 5. Well, since those two are not the same, we're going to write that the overall limit does not exist. So we're going to say, our overall limit does not exist, and then we're going to move on because the left side doesn't equal the right side. Now, if we look at 8, it looks like from the left side, the graph is approaching infinity. From the right side, the graph is approaching negative infinity. So again, on that one, we're going to say does not exist. So let me scroll out. You can see the whole thing. Get you a chance if you needed to pause the video and kind of examine that a little bit further, you could. All right, let me do a couple more things here. Let's talk about piecewise functions. So let's talk about what if I gave you a function, I said f of x is equal to 3x minus 2 and x squared plus 4. And let's say we'll use this one when x is less than 2, and we'll use this one when x is greater than or equal to 2. And if we were trying to figure out what's the limit as x goes towards 2 of this function f of x, we really have to evaluate formally. If you have to write this out on an FRQ, we really have to evaluate this in a formal way. And so this is really where you're going to have to kind of train your brain to kind of answer the question as if you had to write the work down. Because what we would need to do is we really would need to take a look at what's the limit as x goes towards 2 from the left side. And then we'd have to look at what's the limit as x goes towards 2 from the right side. And we really have to evaluate both of those limits, and really important to write those out, because writing those out is going to help you determine if the limit as x goes towards 2 even exists. So you have to kind of do these in two parts. You have to do the first one, and then you have to do the second one, especially if you have to write this out in an FRQ. So the limit as x goes towards, if you look at the limit as x goes towards 2 from the left side, what we would end up using is the top function, the 3x minus 2. So what we'd really need to do is figure out what was 3 times 2 minus 2 equal to. And if we get that, it's actually not even approximately equal to, it's actually just equal to it. If we evaluate that, we get 6 minus 2, or 4. Now if we look at the limit as x goes towards 2 from the right side, we know that that just equals whatever happens when we put it into the bottom function. So 2 squared minus 4, so we do 2 squared, is it minus or plus? 2 squared plus 4, which is 8. So because of this, because these are different, or they are not equal, then the limit as x goes towards 2 of the function f of x does not exist. But you really have to do that full analysis. Writing out the limits, writing out the one-sided limits is going to be a super important thing for you to do to communicate if you're asked a question like this on the AP exam. Okay, so let's look at a couple more things. I'm not sure where these will fit into the process, but if you're looking at vertical asymptotes, vertical asymptotes are when if the limit as x goes towards some value of f of x is either equal to positive infinity or negative infinity, you get a vertical asymptote. So, that's where you guys know what the graph looks like. It's if a graph increases without bound, or consequently if a graph decreases without bound. There may or may not be a dotted line in there, signaling that that's a vertical asymptote, but that's what happens when you get a vertical asymptote. Horizontal asymptotes are a little bit different. Horizontal asymptotes are the case where if you're looking at what happens as x goes towards positive infinity and what happens when you take the limit as x goes towards negative infinity. So that's really what we're looking at in this case. And those are going to be finite values. These are just going to be numbers, right? So know that these two values are just numbers. They might be different. Okay? They might be different. The kind of thing when you're looking at a graph and it might be the kind of thing where the graph kind of, I don't know, approaches like this, and then maybe the graph goes up here and approaches this. So if you looked at this graph, for example, and we counted up 1, 2, 3, 4, and we went down 1. If we think about this, the limit as x goes towards negative infinity of f of x, I would say that equals -1. So the y equals -1 is a horizontal asymptote. Remember, if you look at the limit as x goes then towards positive infinity on this function, what you'd have is 4. That means y equals 4 is a horizontal asymptote. So remember, you're looking at limits as what's happening as x gets really, really big, or what's happening as x gets really, really small or closer to negative infinity. Hopefully this helps. If it's not enough information, I think that's enough information for you to do the assignment. It's just a quick review. I'm not sure where these are going to fit into the AP exam, but at this point you should now do the Delta Math assignment. Sorry. Okay, so go on to that Delta Math assignment and give it a try. And let me know if you have any questions. Look forward to seeing you soon. Take care.